Hi, everyone. I hope you all can hear me. If you do, please press the thumbs up button. And if you can see the presentation, let me know. So we can start now. I'll be talking about personalized recommendations in terms of flavors and in terms of how to get them to scale. In the interest of time, I would be looking for the questions and answers in the end. So I hope to keep some time. I've also created a breakout room so that we can go there if you have any further questions, and I'll be more than happy to answer them after the session as well. So I'm going to start presenting from my screen. So as probably all of you know, Levi's is a pretty legendary company and is very well known for selling denim. We also sell 3 brands under the Levi's umbrella. So Levi's, Dockers, and Denizen. And we also sell another brand called Signature, which is widely sold in Walmart. So we decided to as an AI team, when we started this team in Levi's, we decided to tackle personalized recommendations as our first ever problem. And this is something that we stood to scale 2 years back. And we've been constantly improving over it over time, some of which I've mentioned in the slides, some of which I'll talk through if I've not mentioned them in the slides as well. So before we get into how we did our algorithms, it's better to know what was the story before we even came in to the picture. So Levi's as a company was using Adobe, which is a very well-known provider of recommender systems and tracking on the websites and so on. So we're kind of using Adobe's out-of-the-box stagnant bestsellers recommendation. So it's kind of consistent for all users. It's not personalized or it's not contextual to what the user is doing at that point in time. So you can see this is kind of the recommendation template. And this was what was there across the website, irrespective of the page the consumer was in, irrespective of what they've been shopping. It's just the same recommendations for every single consumer all across the website, giving us a lot of opportunity to go into personalization. We also sat and did a lot of user research to understand what exactly about these recommendations do users like and what do they not like. And these are some of the inputs that came out of it. So the title is kind of generic. It says recommended for you, but it's not personalized recommendation. So possibly causes some misleading for the consumers that why am I seeing the same recommendation over and over again? And it had some mixed gender products without understanding of how they are populated. So there's a men's jeans and then there comes a women's jeans. Then there are 2 men's jeans and then there comes a women's trucker. And again, there's a women's jeans. So a lot of mixed gender products without any understanding of why they are being recommended to the consumers. There was also a mix of sale and non-sale products and product refresh. That is the products that are getting refreshed to Adobe from our end happens only once in 24 hours. But we change our prices dynamically during the day. So sometimes the wrong prices get reflected here, which causes a lot of concern for the consumers because they click on the recommendation and they see a different price when they go into the product page. So this is from very well-known research that 38% of the consumers say that they won't return to an online retailer that recommends things that don't make sense for them, and it comes from Bazaar Voice. And it's the same thing over the last 2 years as well, that just the percentage of consumers who expect recommendation has drastically increased. Now, nearly 50% of the consumers really expect recommendations when they come to a website. So our goal was very simple. We need to help our customers in their product discovery journey by recommending them relevant products, which is personalized to their customer journey. And we'll talk about how it gets personalized to the customer journey as well. But what is exactly the motivation to go in-house? Apart from the experience that you saw, which is definitely substandard to what we want to provide to our consumers, as an in-house team, we have access to a ton of data. We collect a lot of data from the users through their cookie IDs. We collect a lot of data based on their purchase behavior patterns and a lot of implicit data and also a lot of explicit data because they come and leave their reviews on our website. They show their interest by clicking on likes across the website, and they show their interest by clicking on our email campaigns. So a lot of data that we can use and enrich their experience. And definitely the main reason for our AI team was because we wanted to establish this collaborative nature because we're very new to the business. All of us were really young and dynamic, and we wanted to understand how this really 165-year-old company worked. So it was a great opportunity to collaborate with various teams like A/B testing team, engineering team, merchandising team, planning team, who are like really motivational in order to understand like what kind of products do users want to see and what are they thinking about when they design these products. And the third point, of course, is high level of customization. So we offer our business users a lot of ability to switch the ranking of our algorithm, boost certain things. So if you go to our website right now, we have boosted masks all over the website, and that level of customization comes when it becomes in-house. And building a fundamental capability. So we weren't looking at recommendations as something that would serve this purpose, but also as I talk through the slides, you will understand like how we are using various components that we built for recommender system for things that we haven't thought of, which was like building a trend forecast based on image embeddings and similarity between products. So those are things that we can add if we build it as a fundamental capability and as a fundamental product and not just tackling one single problem. And then we also thought of the ability to do continuous testing, continuous A/B test, multi-arm banded test in order to understand which version really wins and not having to stick to one single version. And then, of course, having the ability to do modular deployment and not wait for a vendor to do it in their cycle and get back to us. Some examples of customizations that we did are in-session personalization. So basically, as I showed you, there was no personalization aspect at all. So through our product, we are able to offer in-session personalization. We don't offer hard mark products, for example, for our new visitors, because we want our new visitors to see all our full price products instead of just shopping the sale products. And then we also have, we don't want to show any gated experience products. So we have various collaborations that we do on a continuous basis. For example, we do our Snoopy collaboration. We are currently going into our Lego collaboration. And those collaborative products sometimes require the email ID so that we can track what the user's interests are. And we don't want to show those in the homepage, and we want to control those. So whenever the gated experience goes alive, we want to control that. We also want to ensure we have size brokenness check. Again, this was a very common complaint from our consumers that we show them products and then they click on the recommendation, go in, and then they see that it's not available in their size or not even available in the most common sizes at all. So we have an algorithm which figures out like what is the size brokenness of a product. And if it's extremely size broken, meaning it's not available in the most popular sizes and has very less quantity of inventory, then we won't show that product. And then inventory check before serving so that we know at least 5 units or 10 units are present right at the time of serving the recommendation and not like doing a stale inventory check once a day. And then we also want to have dynamic UI titles with continuous testing so that we know what exactly is a title that makes users to look at our recommendations. So now comes the most important point, which is how do we exactly personalize? So there is 4 buckets that we divided this whole problem into. We thought our consumers had different parts of their journey. So the first part of their journey that we'll be talking about is first-time visitors. So first-time visitors are people who have never come to our website. And the way we figure out they've never come to our website is using cookie ID, email ID, login behavior, and so on. So if they've never come to our website and are shopping with us for the first time, or they've cleared their cookies, in which case we can't track them, then we would call them under the awareness bucket. The second bucket is consideration, which is they have some browsing behavior with our website. They're in the early exploration phase. They've still not purchased anything from us. The third one is intent. So they've added to cart. They're extremely close to checking out, and we are trying to recommend products to those people. Then the purchases. So purchasers is our very loyal segment. They've already purchased with us. They're returning back to purchase more, and then we handle them in a different way. The reason we decided to personalize this way is because our consumers really showed very different purchasing patterns when they're in each of these buckets. For example, someone with intent bucket, they would probably have 50% higher probability to end up purchasing in the next 7 days than in any other time zone. So it's very important that we capture them at that point in time. And that's why this has been divided into these 4 segments. There are multiple other segments that we are considering as well, but we started with these 4 segments. Now let's talk about what is the algorithm behind these segments. So the first segment is awareness. So it's basically new visitors. So we don't know anything about them. We have none of their likes, dislikes. So we go with popularity-based recommendation. So it's as simple as we use like 10 or 15 different metrics, such as AUR, which is average unit retail, UPT is units per transaction, CTR is click-through rate of that product as a whole, and so on, and use like nearly 20 different metrics. And we rank all our products based on these metrics, based on their purchase, how often they've gotten purchased, what is the price at which they got sold, are where they're highly sale item, how much inventory is present, and so on and so forth. And then figure out what are our top 40 products. And then we rank them based on location, device, and seasonal purchase patterns. So this is very important, and we discovered this is important through our many A/B tests, is because um, in California, which is our largest market, we would be always selling tank tops. But when a person from New York is coming in, they don't want to see that for the first time. They would rather want to see something dependent on the climate. So we would show them truckers if it's getting colder, and we would show them tank tops if it's hotter. And regions like Arizona would permanently have shorts being shown to them. So it's very important to capture all of those nuances, and we do that by looking at purchase patterns. And then it's also important to capture location, as I mentioned, but also important to capture device. So in device, in our mobile version of the website, since we are just coming into the app world, we still have a huge proportion of our users only using our mobile version of the website. And when they go into the mobile version of the website, they probably can see the first two products very well. So it's important to show the most attractive products in the first two positions, whereas in the desktop, you can show them over the entire carousel and they would still have visibility into it. So really nuances around that is the first part of the algorithm. And it's a very simple algorithm that's most commonly used everywhere. And this is kind of how it looks. So you can see that there is no sale products, and there's very clear definition of why these products are being shown. And it's very clear from the title that it's recommended bestsellers and not like recommended for you or anything, because it's not personalized, because we don't know anything about them. Then also you can see that there's jackets being shown first, because this is shown for New York. And then you can see that there are jeans being shown next. So it's very clear, like, okay, this is how we are showing. And then we also can see that there is one male product, one female product, one male product, one female product, so that we can maintain the diversity of the products that we are showing as well. So we worked a lot with merchandising to determine the order and the diversity at which they want to show. So next, going into the next part of the journey is consideration. And consideration is basically, we have only browsing behavior and the users are in early exploration phase, as I had mentioned. And this is a very important part of our journey, because this is where we are going to hyper personalize their behavior. So we know that these people are currently browsing, and everywhere they go across the website, we want to track what they're browsing and keep changing their recommendation based on what they're browsing. So this is this behavior is shown only for visitors with past 1 month or in-session browsing behavior. What we do is we take all their in-session browsing behavior and we use content-based filtering in order to recommend products for them. I will talk in detail about what is content-based filtering in the next few slides. But the ranking of the products is based on the last product they interacted with, weighted by intent. So let's say they interacted with a trucker jacket as the last product through a view event, and they added a jeans to their cart, then we would weight the jeans event higher than the view event of just the trucker jacket. But together, they would get a mix of products that they would like to see. So content-based filtering is basically a way in which you don't have much information about the user, but you're still trying to recommend products to them based on the products that they have purchased with, because this is kind of real time. We don't know anything about the user, but they're currently browsing something, so we know what products they like. We don't want to do this user level collaborative filtering, because that takes a lot of time to return results, and so we kind of stick to content-based filtering. So we have purchase behavior, text embeddings, and image embeddings to use for it. So the first one is purchase behavior. So for purchase behavior, we use collaborative filtering model. And inside the collaborative filtering model, we have many approaches to use. We have memory-based approach and model-based approach. Memory-based approach is basically you are trying to find cosine similarity for every single user based on their weighted average of ratings. In our case, it was weighted average of clicks. And model-based approach is to find, you try to train a model and then try to predict what will be their interest towards that model. And then we also have user-based filtering and item-based filtering. So we tried both of these versions, and we also tried memory-based and model-based. In our first version, we decided to use memory-based because we really didn't have that many transactions happening. And this is something that we are doing as a batch job and storing anyways to find product-to-product similarity. So we decided that it's okay if it's memory intensive. And then we moved to model-based down the line. Then between user-based and item-based, we decided to do item-based filtering because that made more sense with our users, because our users did not exhibit similar patterns among themselves, but they had similar patterns when we look at the items that they are purchasing. And then the interesting part is text attributes. So for every single product that we prepare, in this case, a wedgie fit straight taper jeans, we have about, I've listed around 15 attributes here, but we have more than 100 attributes that describe a jeans, like where is it distressed, what is the price of it, what is the leg opening, how is it cropped, how was it designed, what was the wash, and so on. So we can combine all of these using text embedding approach. So in this case, you can see a simple example where you are trying to find a product which is 100% cotton and also high rise, and then it would all automatically fall in this tiny cluster. So if you can get an embedding of all your products, so we use multiple embedding approaches. So we used word to vec. We started with simple TF-IDF, which actually worked really well, and then moved on to word to vec, and then moved on to other techniques like BERT and so on to get the text embeddings of a product. And then we use simple cosine similarity in order to find how similar is that product to another product. And then using the cosine similarity, we then rank the products based on their similarity. Next, going on to image embeddings. Now, image embeddings is also another cool part where we are using what we call as transfer learning. So you can see that in this particular example, this particular network has been trained to identify between giant panda, red panda, and raccoon. So that's exactly what this, and it's been trained on like the huge image corpus. Now, what we can really do is we probably didn't have that much of images. We have only about 5,000 to 6,000 images in our product catalog, but we really wanted to understand what is the nuances between those images. Like, for example, if something is distressed and is not reflected in the textual embeddings, we want to capture in the image embeddings. So what we used is commonly known as transfer learning, where we took a huge corpus of images and passed it to ImageNet and multiple other known versions of neural networks, and then we classified it using like just tops, bottoms, and so on, and then just took that weights that performed really well on this huge corpus and applied those weights to our neural network on our small corpus, and then classified it according to what we want. So basically take a huge large input of 100 plus categories that we got from open source data sets, and then use a ResNet, and then use a softmax, and then find out the different categories and see how well it performs, and then cut the layer of softmax back, and then only use the weights that we have gotten here, which are frozen weights, and then put our own new softmax layers, which will categorize it into a completely different category, which is jeans, tops, and shorts. Whereas the original data set can be categorizing something else, which is like red color, blue color, and so on. So it's only the weights that matter, and we could use them to train our model much better. And it's also much faster. And then what we did is we applied one more neural network in which we can combine both the textual and the image embeddings, and then try to find how similar is one product to each other, in addition to the purchase level behavior using collaborative filtering that we've spoken about. So we used all of these together and then found what is the similarity of one product to another, ranked them based on purchase behavior, and then stored it in already in the in the database. So whenever a user comes in, as soon as we weight their intent by action, we just have to find out what is similar to that product based on all this research, which is done in not in real time, but done in a batch process and stored, and then find what is similar to that and just show it to the user. So it's super fast to the user, but we've done all the hard work at least twice, or we do it twice or thrice a day. And this is kind of the results. So you can see that this particular person is brand new to our website, but is currently browsing and looking at like some girls products. And we can see that they are kind of liking the big girls and the little girls product, probably have 2 kids. And we are able to show what they're looking at based on this product similarity, and show them based on their intent, what is the products that they would like to see. Now, the last stage is purchase, which is basically people who have purchased with us before and are returning customers. So here we kind of use, this is the intent bucket, which is visitors who have added to cart in the last 7 days. Here we kind of use the collaborative filtering that we showed before, which is using item-based collaborative filtering. We have since then come a little bit afar. We are kind of now using embedding-based approach even for this collaborative filtering, where we're trying to find the embeddings based on all the behavioral patterns they've exhibited when they added to cart, and then try to find similar users based on that, and then recommend products to them based on that. And this is kind of how it looks like. So they've added something to the cart, and they probably added a top and a jeans, and we used both of those contexts and found similar users and recommended similar products. And the last one is purchase, which actually follows a similar pattern to the add to cart. It's just that we use last 6 months of purchase patterns. And we also try to rank what is their actions that they do even after purchase. Let's say someone purchased only 6 months before, they're coming back and they keep on seeing, because they fall under that bucket, they keep on seeing the same recommendation. So what we do is we combine the interactions even after purchase and then rank it based on intent. We use a simple exponential function to rank the time decay and also the intent decay, and then find what are the top 10 products that will be liked by the user, and then perform collaborative filtering on that. And that gave us much better results than just performing straight up collaborative filtering. And this is kind of what it looks like. So this person is basically cross-shopping across genders. So they really like men's products, and that's what they've purchased. But suddenly they've shown an interest to buy for someone in their family. So they've been looking around for a female t-shirt. So we are able to find both the patterns and recommend, and not just over-index on what they purchased. So what is the result of all these cool things that we've done together? All of these put together is in one place in the website, and is showing personalized recommendation for the user. And we found tremendous improvement in conversion, which is our primary metric. We increased conversion by 4.5% at 99% confidence level, and our RPV increase, which is revenue per visit, increased by 4.4% at 97% confidence. So our confidence levels was 95%. So we definitely were statistically significant on both of our key metrics. And this product by itself is currently worth around $6 million across all our website. So thinking ahead, what are the other things that we're thinking of? We've definitely had many tests and many successes. So we've moved from home page to cart page, product detail pages. All of them have completely different algorithms, completely different experience based on what the user is looking for. We've scaled to our email campaigns. We even have scaled to our stylist apps. So when you go into our store and say that I really like this jeans, can you show me something else? They automatically connect to our database, and they're able to see what they can recommend to you in a real life scenario. Then we also use it for our customer service agents to recommend products in case something goes out of stock and so on. Then we are also using in other interesting areas, as I had mentioned, which is trend forecast, marketplace analysis, using understanding of how products are linked to each other really helps us to give an edge over these trend forecasts when new products are released. Then we're also scaling across brands, geographies, and platforms. Algorithmically, we are trying to move ahead and use user-generated images in addition to what's being shown to show style recommendations, because a lot of people tag us in Instagram and are willing to give us their images, and we can use that to understand what do people like to style them with, and that can go in recommending products, but also can go into product design by itself. We are also using many ranking algorithms like Bayesian personalized ranking and other ranking algorithms right now. And we've also used purchase propensity based recommendations. So it's like we have separate scores for every single user when they come to our website. And using those scores, we recommend different products to them. We also have lifetime value based recommendations. So that's my presentation. Thank you. And I'll take any questions that you guys have.